So hello students, once again, welcome back to the session, and I hope you have seen the other two videos of the same session, that is matter in our surroundings. So this is the third subtopic which we are going to deal here, interconversion of states of matter. Now, we were discussing earlier in the previous sessions that water can exist in three forms, right? It can be a solid, it can be a liquid, and it can be, you can say, gas, right? Now, you have also seen that this water is getting converted into something, right? Some form. So how is it turning, like a solid state is turning into a liquid, a flowy state, and that flowy state is again turning into a very free state, that is gases. But the water is same. Like, we never say that the formula is changed, or water has become some other material. No, we do not say that, right? So let's explore that, how that happens. Okay, so let me just, okay, right. So here, matter around us, we know what exactly, so far we have done that. Matter is there, right? The characteristics of matter, there is space between them, matter, the force of attraction, movement. According to them, we have classified different states of matter. That is solid, liquid, and gas, right? We have seen that solids have fixed shape, right? Liquids do not have fixed shape, but have fixed volume, and gases do not have fixed shape or fixed volume, right? Okay, now moving ahead to how we can change solids to liquid and liquid to gases. So there are two key factors, or two, you can say, driving forces are there, which helps us changing the state of any substance. The first one is temperature. Okay, and the second one is pressure. Now this temperature and pressure is going to be there always, like from now onwards, from these classes, it'll start being incorporated more into your classes, okay, or more into your topics. Okay, so clarify these here itself. Okay, so temperature, when we heat actually something, okay, what happens? The energy of the particles start, getting high. Now, once the energy is high, the particles will start moving faster. Okay. Even, for example, imagine yourself, okay, you are standing and I will bring, it's very hot, okay, hot summer is there, and I'm bringing a heater near you. You'll start running, right? You'll start getting away from that. So your energy increased to run away from that heater. Or maybe you can imagine, like, that somebody is angry and scolding you, right? And now you want to run away from that place, and everybody is starting to hide. Or maybe our siblings, one of us is getting scolded by parents, so other one starts, doing something, or being active, actively studying or something. So similarly, particles are like that. Here, if you will provide heat to them, okay, all the particles will go crazy and start, trying to run away or move fastly, very fast. Okay, and since they are moving here and there very fast, they are not understanding what to do. Oh, this is a situation of panic among these particles, right? So what happens is the bond between them breaks. Okay, and because of that, there is change in the, you can say, change in state. And that is what we wanted to achieve, right? We wanted to convert the state from one state to another, right, of any matter. So heating something will help us, or raising the temperature of any particle will help us converting one particle into another. Now, for example, solids gets converted into liquid. For example, if you take an ice and you keep it at room temperature, it will start melting. But if you take ice and put it in a pan, maybe, okay, let's put it in a pan, okay, like this, okay, and we are heating it. We are trying to heat it. Now what happens? It will melt faster and faster. Why? Because the heat is disturbing the particles present here, and the particles started moving here and there randomly, and the force of attraction between the particle breaks. And because of that, it will turn into a liquid. Now, cooling. Cooling decreases the particle energy, causing them to slow down. Okay. For example, you took the same water. Okay. Now you have taken the water. Let me just erase this. Okay. You have taken the water, right? And you have kept it in a freezer. Maybe you have put it in this tray, ice tray. And like this, you have filled it with water like this. Okay. Now, cooling decreases the particle energy. For example, imagine yourself in winter. Okay. In winter, what happens? Your energy also becomes very, very low. What you try to do is sit under a blanket, turn on some heater, right? And try to rest. You do not move here and there, right? So again, here for particles also, they do not like, they just stay like that. Okay. They do not move here and there. Now, if they do not move much, so the force of attraction will strengthen. Okay. And because of strengthening of the force of attraction, they'll stay together, stick together, bond with each other, right? And then there will be change in the state. So for example, if gases, we are cooling it, it will become liquid. And if we are cooling water, like I told you a lot, after a certain point, it will become solid and it will turn into an ice. Okay. So example is ice turns into water, that is liquid. And then gas is steam. By heating, you can like reverse the whole thing. Okay. Now reverse by cooling. Change in pressure. Increasing the pressure, what happens? This pushes the particles closer. Now this you have to understand because sometimes students get mostly confused in pressure. Okay, what exactly pressure is. So what happens is, imagine again, let me take just another color maybe. Okay. So let's take the particles like this. Okay, these are particles. Let's take these are gas particles. Now, once I will start applying pressure to it, okay, they will start getting close and close, right? If your parents or if your teachers put pressure on you, you start getting, close to your books, right? Just like that. Okay, so they'll sit now closer and closer, like together, like you will sit with your books, right? So here, the pressure is, the more the pressure, the more the particles get closer to each other. Even like, for example, imagine in a room, okay, if there is more, space, everybody is sitting here and there, right? But if I shorten the room, maybe like if room is like this, right? And everybody's sitting like this. But now I start, pushing the wall. Maybe this is imaginary case, but let's start pushing the wall. Now everybody get closer, right? They'll start sitting here, maybe, then here, right? Like this. So every particle will get closer to each other, okay? And because of that, a change in state can be seen. Decreasing the pressure will also help in changing the state. This allows the particle to move farther. Now I have started making this wall again, wider. Okay, maybe this is a movable wall. Okay, so yeah, maybe wall made up of plastic. Okay, so now once I'm moving it here, again, everybody gets enough space, right? So they'll sit maybe on the couch, somebody will be on the bed, somebody here. So again, the particles will move away from each other. So that is the whole concept here. Now, liquefied petroleum gas cylinders store gas as a liquid under high pressure. Okay, allowing more gas to be stored in a small volume. So what they do is they take the gas cylinder, okay, and they will just put it under so much high pressure that more and more particles can come and, stay in the same size cylinder. Okay, same volume, right? So I hope this is clear. That change in temperature and pressure helps us to change the state. Okay, now coming to the interconversion, how we'll do it. Okay, so first let's start with solid. Okay, if we are taking solid and if we are melting it, okay, melting. How do we melt something? By providing heat. The concept we discussed earlier, right, about temperature. So if solid particles are like this, right, you will provide heat to it. Let's say heat, right? And particles will start vibrating. And once they vibrate, right, they'll start moving away from each other. And once they start moving away from each other, they will turn into liquids. right? Liquid. Now the particle is far, far away like this. Not so far, but enough, right? Now again, if you heat it more, so this is called as melting or fusion. For ice, 0 degrees Celsius at normal temperature, this melting occurs, okay? An ice cube starts melting into water. Now, coming to the vaporization or boiling. Okay, so from liquid to gas, if we want to turn something, let me just pick a color. I hope this is visible. Okay, gases. So the particle will move further away because again, you are providing heat here, no, to liquid. So the particles will move away. So for water, if you try to boil it, right? So at 100 degrees Celsius and at 1 atmosphere pressure, the water starts boiling and getting turned into steam. So when you will put hand on a boiling water, right, you will feel very hot because this steam is also having this 100 degrees Celsius, right? And this is moving. Okay, so that is the change in the state again. Now coming to the freezing. Now, what if we want to change the state in the reverse way? What if we want to change gases to liquids and liquids to, let's say, solid? Okay, so first let's try to change liquid into solid. So what you do, you take water, right, and you put it in refrigerator, and then after an hour, maybe 2-3 hours, you will see that there is a solid ice is formed, right? Ice is formed. Here this is water, and these are steam, you can say. Okay, right. So here the liquid to solid by cooling. So once you start cooling it, once you put the temperature lower and down, the water will turn into ice. Like for example, in the freezer, you have seen it. Okay, condensation, that is gases getting converted into liquid. Now the best example would be what? It would be rain. Okay, so condensation is the process which helps raining basically. So what happens here is that gases here, you will again, what you will do is you will start cooling the gases. And once the gases are cooled down enough, what happens? They will get converted into liquid form. Okay, so for example, water droplets on a cold glass in summer. What exactly is happening when you take, if you take a free water from a refrigerator, right? So this is very, very cold water. Let's take it in maybe blue color itself. Okay, so this is cold water, right? In summer, hot summer. No, this hot summer, this heat is making the outside particles, the air or gases turn into liquid and stick to the water, the glass like this. And that is what you see, right? So I hope this is clear. Again, let me just tell you that solids get converted into liquids with the help of melting. Okay, and liquids gets converted into gases with the help of, you can say what, vaporization. Okay, let me just vaporization. Okay, and gases gets converted into liquid by condensation, and liquids get converted into solid by freezing or solidification. So this, if you can remember this whole thing, the chart or the map, then you'll be able to remember everything and maybe expand it a little bit more in your examination. Okay, now there is one more thing. Sometimes what happens, there is no state change in state in the interstate, that is between state from solid to liquid, and some things get directly converted into gases. Okay, so they do not go under this stage. No, they directly go to gases. Solids directly gets converted into gases. They skip that one part of becoming liquid. Okay, so when this process happens, the name would be sublimation. Sublimation is the process of solids getting directly converted into gases, skipping the part of becoming liquid. Okay, the example would be camphor. Okay, the camphor which we use in, the basically while you are doing the praying. Okay, so when you offer to God an aarti maybe, right? So that like the Hindu people usually do that. So there you would see that that gets converted directly into the gases. Okay, the whole flame and the camphor. It does not get into a liquid state. Okay. Dry ice, this is nothing but a solid carbon dioxide. Okay. This also gets changed into, gases, and it is helpful in making the theatrical effects. So in theaters, no, you will see a lot of drama, the smoke and everything, right? So the smoke or the fog, how they are creating that, actually they are using dry ice and converting it into, directly into the gaseous state. So that's how, science is being used in different areas of real life. Okay, naphthalene balls also, they also like directly gets converted into the gases. So all these things are not doing nothing but sublimation process. Okay, right. Now moving ahead. Okay, now coming to the topic, which is latent heat. So latent heat, I'd suggest, like, we have to study a lot about this in depth. Okay, but let me just try to explain you in a concise way. So latent heat is the hidden heat. Okay, for example, suppose you are teasing your friend. Okay, now you're teasing them again and again and again, but they're not showing any response or changes in their behavior. They are just sitting silently. Or maybe you're teasing your parents, your mother, right? Kids used to do, or they love to do it a lot. Okay, so you're teasing again and again and again. After a certain point, they will break. Okay, in anger, they'll scream at you, or maybe they'll shout, or they'll just say, okay, don't do this. This is enough, right? So latent heat is the hidden heat which is being provided, the hidden energy, the hidden heat energy that is absorbed or released during a change of state. So once the change of state is being done, right, this latent heat is being absorbed or being released without causing any change in the temperature. That you have to understand. So for example, if we talk about latent heat of fusion, this is heat energy required to convert a solid, okay, into liquid. Fusion is what? The process of converting or melting. Fusion is melting, okay, converting a solid into liquid. Okay, now the heat energy required to convert a solid into liquid is its melting point. Now here, if you'll see an example, when ice melts at 0 degrees Celsius, it absorbs latent heat of fusion because it needs energy, right? It needs energy to melt down. So it is taking the energy. Now, once it's taking that energy, heat energy, the temperature of the ice water mixture will remain 0. That we need to know. Okay, that we need to understand that the temperature of ice as well as the liquid it is getting converted into, that is water, will be 0 degree and 0 degree. The heat they are absorbing, right? They're absorbing the heat, but then the temperature remains same until every ice or each, part of ice has been converted into water. So whatever heat is required to complete the whole ice into water is known as latent heat of fusion. Now, if you have understood this concept, you'll be able to understand the latent heat of vaporization. Okay, so the latent heat of vaporization is the heat energy required to convert a liquid into gas at its boiling point. Okay, now you are converting a liquid into a gas. Now again, here the temperature of the liquid while it is getting converted, right, it will be same 100 degrees Celsius, and here also the gas which is it is getting converted into the liquid will be 100 degrees Celsius, but the amount of heat which is required here, okay, to do this conversion will be latent heat of vaporization. Okay, just like your mother is there, right, and the amount of anger, okay, you are going to give her, okay, and the change in the state would be here also she's angry, here also she's angry in both the state, but here you need some amount of, you are putting something in, and then she became 100% angry, and now that 100% anger will be seen here as well. So that is just an analogy, just to make you understand. I hope you understood the concept. Now the effect of just a second, let me move this. Effect of pressure on boiling point. Okay, now and melting point as well. So melting is actually not mentioned directly in your syllabus. So we'll study in depth later. We'll study about the boiling point. So boiling point, the higher pressure increases boiling point. How it does that? It needs more energy needed to overcome the external pressure and allow the liquid to get converted into gas. I'll tell you how it works. So for example, let's say here you have kept, let's say you have kept liquid, right? Now this liquid particles, they want to go out, break free, right? And they want to become what? Gases. They want to go out and randomly move like this. But there is a very high pressure, external pressure here. So this will keep the particles close, right? The force of attraction will be more, and the particles won't be able to move out easily to become gases, right? So then the boiling point will increase. The boiling point increases. We need more, temperature again here, so that they can, break free through the force, or not exactly force, the pressure being applied on them. Okay, and then go out and spread as steam or gases. Okay, the lower the pressure, like for example, now you're not putting any pressure, so then less energy would be needed and the particles will easily get converted into other state, that is gases. Okay, and that's why the food at hill stations, the atmospheric pressure at hill station is very low. The pressure is not that high where, how it is here on plains. Okay, so the water boils at less than 100 degrees Celsius, which is why food takes a very long time to cook. Okay, right. So I hope this is clear. Moving ahead. So this is what we have studied so far. We have studied about temperature and pressure, right? We have studied about latent heat. We also dealt with the melting and freezing. We also dealt with like how we can change the state of any matter. So melting and freezing is for solids to liquid, right? Interconversion, like it can be solid to liquid, liquid to solid, reversible. Then boiling and condensation is for liquid to gas and gas to liquid, vice versa. And lastly, sublimation and deposition. Deposition we haven't seen, we'll see in in later in-depth classes. So sublimation is for solid to gases, direct conversion. There is no liquid state involved here. Okay. Right. So you can see how science is actually involved in, a lot of places, even in cooking at our house. So our even mother or father, whosoever is cooking, even if you for till then, thank you so much for joining the session. I hope to see you soon in the next session. Okay. And if you have any doubts, you can contact me through my Urban Pro profile. Thank you so much. Bye-bye. Take care.